Hey everybody, welcome. Today we're talking about solving systems of linear equations. So this is a little bit of a sidetrack from our everyday geometry, but we're going to have to review this algebra in order to use it to solve some geometry problems. So let's get started. A system of equations is a set of two or more equations with the same variables. The solution of a system is the set of values that makes all the equations in the system true. Now there are three ways to solve a system of linear equations, and the first way is by graphing. Graphically, the solution of a system is the point of intersection of the graphs of the equations. So in our example here, we have a system of equations, y equals 2x minus 7 and y equals negative 3x plus 3. Now what we're going to do is we're going to enter these two equations into y1 and y2 on our calculator, graph it, and find where they intersect. So let's do that. So I've entered them into y1 and y2. I'm going to use my standard window, zoom 6, and there's my graph of my two lines. Now, the point of intersection is the solution to the system. Now, this graph is pretty clear. We can clearly see that that point of intersection is at the point 2, negative 3. Now, we can double check this. First, we could use the trace function. We could tell the calculator to plug in 2 for x, and it'll spit out the y value. The other thing we can do is use the calculate function. So if we hit second trace and go down to number 5, intersect, the calculator will actually calculate the point of intersection. Now it asks us a couple questions at the bottom. Notice it says first curve, question mark. If you look up at the top, we're on y1, so I hit enter. Now it says second curve, and notice at the top, we're on y2, so I hit enter. And then it asks me to guess the point of intersection. So we just need to move that cursor close to the point of intersection and hit enter. Well, there it is again, 2, negative 3. So by graphing, we can conclude that the solution to this system of equations is the point 2, negative 3. Now, if you ever graph to solve a system of equations, you definitely need to draw a picture of the graph. All right, the second method of solving a system of equations is called the substitution method. And this method is exactly what it says it is. We're going to substitute one equation into the other. Now, in order to do that, we need to solve one of the equations for one of the two variables, either x or y. And it doesn't matter which one we solve for. But looking at that top equation, 3y equals 12x minus 21, it looks pretty easy to solve for y. If I take that equation and I divide both sides by 3 to get the y by itself, these 3's will cancel, and now remember that the 3 in the denominator will apply to the 12x term and the negative 21 term. So when we simplify, we're going to get 4x minus 7. Now that we solved this equation for y, we can take what y equals, 4x minus 7, and we can substitute it in for y into the other equation. Now that equation would read 12x plus 2 times 4x minus 7 equals 1. Now I have an equation with just x in it, so I can solve. I'm going to distribute my 2, combine like terms, add 14 to the other side, and divide both sides by 20. So x equals 3/4. Now that's the x value of the solution to this system. Now I have to find the y value. And I can do that by plugging my x value into the equation I had already solved for y. So now this equation would read y equals 4 times 3/4 minus 7. And of course the 4's cancel out, and I have 3 minus 7, which is -4. So the solution to the system of equations that I was given is the point 3/4, comma, -4. Finally, the third method for solving a system of equations is called the addition method, also known, also known as the elimination method. We often call it the addition method because we're going to add the equations together. We often call it the elimination method because we are going to eliminate one of the variables. Let's do the example. So notice in our example here, we have two linear equations, and notice the setup. In both cases, we have the A's lined up, we have the B's lined up, we have the equal signs lined up, and we have our constants lined up. This is the first step in using the addition method. You always want to write your linear equations in this standard form. If they don't come in standard form, then you need to rearrange each one to set them up this way. Now, the next thing is to decide which variable do you want to eliminate. In this case, either the A or the B. And it doesn't matter which one you eliminate. But oftentimes, one of them is a little bit easier to eliminate. For instance, in this case, eliminating the variable B is going to be a little more simple than eliminating the A. In order to eliminate the variable B, I need to have the same coefficients with opposite signs. Well, right now I have 60b on top and 30b on the bottom. So what I need to do is I need to multiply this whole equation by a -2. I don't need to multiply the top equation by anything. It's going to stay as it is. So that would be 140a plus 60b equals 40. The bottom equation would now be -400a minus 60b equals -170. Notice that I multiplied every single term by that -2. Now, I'm ready to eliminate my b's. They have the same coefficient with opposite signs. So I'm going to add my two equations together. 140a minus 400a is going to be -260a. My b's are gone, right? So don't even write a b. Some students make the mistake of saying plus b as if the 0 is plus b. But they're absolutely gone, so I don't even write that there. And then finally, 40 minus 170 is -130. Now I have a very simple equation that I can solve for a. I'm going to divide both sides by -260, and I get 1/2 for a. Now that I have a value for a, I'm going to plug it back into either one of the two original equations to find the b. So I'm going to use my top equation. I have 140 times my a plus 60b equals 40. Now I can solve for b. Half of 140 is 70. Subtract 70 to the other side. And divide both sides by 60, and I get -1/2. So the solution to this system of equations is the point 1/2, comma, -1/2.